Solve system of equations using elimination. I don't see perfect opposites. So what should I do first? Well, I'm going to have to create perfect opposites. Yeah, I'm going to multiply that second equation. I'm going to multiply it by what? I think negative 2 would work, because up top I have a positive 2y. And if I can change positive y into negative 2, that would create perfect opposites. Okay. I'm going to distribute negative 2 to each term inside of my parentheses. So I'm going to create 3 multiplication problems. Negative 2 times negative 5x. Negative 2 times positive y. Negative 2 times positive 20. First one gives me positive 10x. Second one gives me negative 2y. Third one gives me negative 40. I'm going to take my original equation above it and rewrite it with my new equation to the side. Okay, we can now use the elimination piece. We can eliminate the y's. Positive 2y and negative 2y would cancel each other out. And we can combine the other terms. 12x and 10x is going to give me 22x's. Those 22x's are going to be equal to a total, since I have negative numbers for both, a total of 44 negatives. If 22x's are equal to 44 negatives, how much is each x going to be worth? Well, each x would be worth negative 2. And we've got the first of 2 pieces that we need to solve a system of equations, because what we're thinking of is this is going to be 2 lines that intersect at one point, and we need that ordered pair. I've got one of the pieces that I need. How do I get the other piece? Well, we're going to substitute. That's right. I'm going to substitute back into an original equation. Now, I highlighted an original equation up top. I'll take that one and substitute in negative 2 in for x and see if we can't solve for y. Alright, I've written my original equation down below. I'm now going to physically erase the x, and instead I'm going to insert my negative 2. What that does, it takes one of the variables out of the equation, and now we can figure out what is y going to be by itself. When I multiply 12 times negative 2, I get negative 24. So I've got negative 24, I've got 2 y's, and on that side, that expression is equal to a negative 4. Okay, how can I solve this? Well, I'm going to move and ping pong this over the equation. And this is now gone. It's not negative 24 anymore. When it goes to the other side, it's positive 24. So, I have 2 y's. I've got a negative 4 and a positive 24. And when I combine them, I definitely have more positives than I do negatives. I've got a total of 20 positives. If I break this up into single y's, I'd have 2 single y's, which means I'm going to break 20 up into 2 even groups to figure out what y is. And that tells me that y is going to end up revealing itself as positive 10. That's the second piece that we needed. Our ordered pair and our answer, remember x value first, is going to be negative 2, positive 10.